Now let's write all the configuration code for deploying our services to Kubernetes cluster. And let's see all the things that we need to do for that. First, we will need Kubernetes manifest files for deployment and service components for each microservice. We will also need a Docker registry secret inside Kubernetes so that Kubernetes can fetch the images inside the cluster because they're in a private registry, so we need explicit access. We will also need kubectl tool installed on the GitLab runner to actually deploy Kubernetes manifests. And finally, we will need to change deploy job from Docker Compose to Kubernetes deployment. So let's do all of that. So first I'm going to go to one of the services. Let's start with frontend. And here inside the project, we're going to create deployment and service configuration files for Kubernetes. And we're going to create them inside a folder called Kubernetes. So we have it a little bit organized. So let's do Kubernetes directory. And inside that, we're going to create deployment, YAML, and service YAML. You can also create one file and have both of them inside. I'm going to actually split it and have deployment and services separately. So deployment file contents will be very simple, basic configuration of a deployment. Let's see what we have inside. We have the deployment kind. The name of the deployment will be frontend, which is the microservice name. The namespace of the deployment will be my microservice with one replica and the port 3000. And we have this image attribute here, which we are going to make configurable because we are building the image inside the pipeline and we always increment the version. So at least the image version should be dynamically set so we can't hard code it in here. But in fact, we're going to make this whole thing generic so we can directly copy and paste the manifest files for each service. Plus we're repeating some values here. So we're going to make all of this configurable. So instead of hard-coded values, we're going to use placeholders with variables inside. So we're going to have the microservice name and let's substitute it everywhere. Let's also have a service port. Instead of hard-coded value, we can also parameterize the replicas. Basically anything you want to make configurable, you can parameterize. You can even set the namespace dynamically. And we can parameterize the image name and image tag individually. So this will give us more generic file and we can literally just copy and paste this for all the services without any adjustment. So let's create this one. And when we commit this, this will actually trigger the pipeline, which we don't want. So we can cancel the pipeline immediately. There you go. And I'm actually going to do a little workaround so that the pipeline doesn't get triggered on every commit. So let's go to web IDE. I'm going to rename this file and let's just remove the dot. There you go. So now GitLab won't actually build anything because it expects .gitlab.ci.yaml and not this file. And we can make the changes and commit them without triggering the pipeline. So in the Kubernetes folder, we're going to create service.yaml and I'm going to copy the service configuration. Again, very simple. We have the service resource, the name of the service and the selector, the namespace and the ports. And we're going to make these also configurable. And this should be inside Kubernetes. Rename the file. There you go. So we're going to make this also configurable. So microservice here and service port for both. Now, this can be a little bit confusing because we have a microservice as a term. So that's the microservice port. And here we have a Kubernetes service. So that's the same word for two different things. But this is just basically port where microservice will start inside the container and the same port we're using for both container and service. So in our case, this will be all the same values. So the Kubernetes manifest files are done. They are very generic. We can copy and paste it for other services later, and I'm gonna commit them. This should not trigger a pipeline now because I have renamed or disabled it. So if I go to pipelines, nothing is running. Cool. Now, one note here, as I mentioned, we're going to copy and paste these Kubernetes manifest files for other services as well. Now, if you have 50 services, obviously this will be not very efficient to have 50 copies of the same files for all your services. So if you have Kubernetes manifest files that are basically same across multiple services or applications, it is a common practice to have a separate Git repository for the Kubernetes manifest files, which is parameterized, generic, and can be reused for multiple projects by setting the values. You would have a separate project for it, maybe in the group, and you can reference it in any project you need. But in our case, we're going to keep it simple, and we're going to create them in each repository. But I wanted to mention that that's an option as well. Now here's one interesting thing regarding the communication between front-end and products and shopping cart services. In our previous deployments, we used the Docker file that set the endpoints of product service and shopping cart service to container names that Docker Compose was producing for us, right? So these names are actually, or these endpoint names are Docker Compose specific. Now, since we're creating services or Kubernetes services for our microservice deployments, we would need to actually change these values to point to the Kubernetes service name instead. So in the Kubernetes service.yaml, for each microservice, like front-end, product service, whatever, we are calling the service whatever the microservice name is, right? So front-end will have a service called front-end, products will have a Kubernetes service called products, and so on. That is going to be the endpoint name inside Kubernetes for those services. So we're going to have to change those as well. So instead of products underscore app underscore one, whatever, the endpoint name is going to be Kubernetes service name. Because again, if you have watched the prerequisite video of Kubernetes Crash Course, you actually learn there that Kubernetes services are components which let different applications inside communicate with each other, and they can talk to each other using those service names. So we're going to change those two here, products and shopping cart. So those are going to be endpoint names inside Kubernetes. So we're going to make those changes as well. Now, I want to mention here that generally when you have different endpoint configurations and I don't know, you need to connect to a database or some other service, you usually have this configuration externally, not baked into your Docker file, but either in Docker Compose configuration or Kubernetes manifest file configuration. So usually you would set those values from outside, so you don't have to go back and change your Docker file every time something changes here. We're doing this in this case because of the demo specifics and because we just have two environment variables that we are setting only in front end. But just to note here that very often you would have this kind of configuration set from outside, or you can have a combination of both, like having them in Docker file and then you can override it basically in a Kubernetes deployment file, for example, by passing in those environment variables on the pod configuration. So just wanted to mention that as well. Great, so now let's actually get to the pipeline logic of deploying the service to Kubernetes cluster, which in our case means that in the deploy step, we'll simply update the logic that now deploys to EC2 instance and adjust it to deploy to Kubernetes cluster instead. In fact, the good thing here is that since we already have this deploy logic extracted in its own CI templates repository, we won't have to update this 3 times in each pipeline. We're going to have to adjust this only once, and then basically just change the reference to it. So I'm going to go to the CI templates repository, the deploy YAML, and what I'm going to do is actually leave this deploy logic. So we're not going to delete this. We're simply going to rename it. Let's do edit. So I'm going to call this deploy compose or Docker compose. Let's call it deploy compose. So we keep that logic inside if you would need that later or in some other project. And we're going to create a new one. And we're going to call this deploy kubernetes.yaml. And we're going to add the logic of deploying to Kubernetes right here. And the logic for deploying to Kubernetes will actually be simpler than to Docker Compose because we just have kubectl apply commands and we just need a couple of environment variables that we need to set before. So let's go and do that. We have the deploy job, the stage deploy, which we can override if we want to in the implementing job. And in the before script, this is where we're going to set all the environment variables that we need before executing the actual kubectl apply commands. So there are a couple of things we're going to need. First of all, we're going to need values for all those placeholders that we set in deployment and service files, right? So microservice, image name, image tag, service port, all these values need to be set. So let's go ahead and do that. And I'm actually going to copy this from the previous deploy jobs that we had, setting the image name. This is the same thing, same logic. We have the image tag or the service version. We have the microservice, service port. We also made replicas configurable, so we're going to have that as well. And finally, we need to set the kubeconfig environment variable to point to the correct kubeconfig file. So we're going to export kubeconfig, and the kubeconfig file for GitLab is in the variable that we created, in the file variable, and we can reference this simply using the variable name, which we called kubeconfig, I believe. Let's actually make sure to check that. Kubeconfig, right? And this will actually reference this kubeconfig file that we created. And it will set the kubeconfig environment variable to this value. So kubectl command will know which kubeconfig file to use to connect and authenticate with Kubernetes cluster. So these are all the variables that we need. And now we have the actual script section in which we are going to apply the deployment and service files. Now, just to understand the process of execution, so this job, deploy job, will be executed in front end and other services. So let's say inside the front end, this will be executed from the root, right? That's where we have the pipeline configuration. So we're going to write this logic in the CI templates, a different repository, with the thought that it's going to be executed inside the front end and other services when we reference it, right? And that's the pipeline code. So deploy job will be basically made available here. So in order to apply the files, the manifest files inside Kubernetes, we're going to reference them using the Kubernetes/deployment and Kubernetes/service YAML, right? So even though we don't have this inside the CI templates, these are actually the file locations that are relevant inside the front end and other services from where we will execute this job. So this will actually deploy or create those resources inside the cluster using the kubeconfig file that we provide here. Now, the problem here is that even though we are exporting and setting these environment variables, this will not be enough to substitute them as values inside the deployment and service files. So this will not be substituted by the environment variables. We will need to use a tool, a specific tool, in order to make this happen. And that tool is called envsubst, or environment substitution. So we're going to have to use this command to explicitly replace any values that are parameterized inside those YAML files with the matching environment variable values. So microservice here will be substituted with the value of the microservice environment variable set here. So we're going to use that command to make this happen. And as I said, it's called envsubst, like this. So basically the way it works is the envsubst takes this deployment YAML file as a parameter and replace all the values inside that are parameterized like this with $sign and the name of the variable, replace all of them with the matching environment variable values. And when you have that result, when you have the YAML file with the actual values, then we're gonna apply whatever output this gives us using kubectl apply command. So that's the syntax of it. We're going to do the same here. We're going to take the service YAML as an input, and we're going to apply whatever the output is. So this will give us final Kubernetes manifest files with all the values substituted, and we'll apply them. Now there's one more thing we need to do here, because we are deploying images from a private Docker registry, which is on GitLab. This means that Kubernetes would need access to it, right? Because we don't want just any cluster from anywhere to have access to our GitLab, to our Docker container registry. So we need to give that access explicitly. So we need an equivalent of Docker login inside Kubernetes, so that when we create this deployment file that references that image from the private repository, Kubernetes or Docker on the Kubernetes worker nodes can fetch that image from the Docker registry. And in Kubernetes, we have a special type of secret called Docker registry that can hold credentials to fetch from a private container registry. So we will create that secret in the cluster using the GitLab credentials. So right here, before we create the deployment, we're going to execute kubectl create secret command that will create the Docker registry secret. So this is actually the type of the secret. It's not the name. It's the special type of a secret in container, specifically for Docker registry secrets. And this is going to be now a name of that secret. And we can call it whatever we want, obviously. I'm going to call it my registry key. And we're going to have to add, obviously, credentials to the registry. So first, we're going to have the registry location itself, because we need to tell Kubernetes which Docker registry are we trying to authenticate to and fetch the images from. So that's going to be the Docker server. That's the option for that Docker registry secret type. And this is going to be the CI registry predefined environment variable value. So that's basically the name of the GitLab's registry instance generally. Then we have Docker username. So we have the Docker server, which is the value of CI registry. And in our pipelines, we actually used the predefined variables for registry user and registry password. However, we can't use them in this case. And the reason is that, if you remember, I mentioned that the user and password variables for the registry that we get available inside the pipeline are only valid as long as the job is running, right? So once the job is completed, those values are not usable anymore to access the container registry. So we can't use those values in Kubernetes, because once the job is done, Kubernetes should be able to fetch those images. So we need something more persistent. And we have two options here. Now, if I go to any project that doesn't have images in the container registry, and let's take the CI templates, because that one doesn't have any images. So on the empty container registry view, you actually have some information about how to access and authenticate with the registry. One option is to use your GitLab username and password in order to access the registry and authenticate with it. Or if you don't want to use the GitLab password, your account password basically, or you have a two-factor authentication enabled, you can create a personal access token and use that instead as a password. So that will be something a little bit more secure than using your username and password. What we're going to do is, again, for simplicity, let's actually use the GitLab username and password so Kubernetes can access the container registry. Now, you have to note here that this is actually your GitLab account's username and password. So this has access to the projects and everything, not just the container registry. So we're going to use the GitLab username and password. And of course, because these are credentials, we're going to create them as secret variables as well. So in the CI/CD settings of the group, we're going to create two more variables. And let's call this GitLab user, and basically just paste in the value. And we can actually mask this variable because it doesn't have new lines or any special characters like our secret file variables had. So we can actually mask it. And let's update, and let's create another one for GitLab password. And this is going to be masked value as well. And I'm just going to copy my password. And I have my GitLab password and GitLab user secret values, which I can now reference in my pipeline. So the Docker username will be GitLab user. And then we have Docker password for the registry password. And we're going to reference GitLab password for that. Now, since we're using create command here instead of apply, the issue with create command is that if we try to create a resource that already exists with the same name, we'll get an error. And that's the disadvantage of using what's called imperative commands like create, update, delete, compared to declarative commands such as apply. So in order to fix this issue and not get an error after the first run when we have created the secret already, we're gonna switch this, or we're gonna change this command into the apply. So what we're gonna do is we're gonna tell kubectl to generate a YAML file from this create command and then apply that YAML file using kubectl apply. And it's actually very easy to do with kubectl because we have a option, a flag on kubectl commands, on any command that's called dry run, and the value is client. So this is equivalent to getting a preview of the command without actually executing it. So give us a preview of this command in a Kubernetes YAML format. And then once we have that YAML file, we're gonna do kubectl apply of that file. So now this will create the secret using kubectl apply command. So the next time when the secret already exists and this job runs, kubectl apply will take care of validating and checking that the secret is already there and will not try to recreate it. And one thing we shouldn't forget here is to add a namespace, my microservice, because we need to create the secret inside the my microservice namespace so that it will be available for all the containers and pods in the namespace, because you can't actually access secrets from other namespaces inside Kubernetes. So to sum up what we've done here, we are basically setting a couple of environment variables that we need. One of them is setting the kubeconfig file to the context of the CI/CD user's kubeconfig file that has information about where the cluster is, the cluster certificate, as well as the user and user token for CI/CD service account to authenticate with the cluster. And with that information, kubectl can now create a secret for Docker registry and create a deployment and service files that will basically pull the image from the registry, create pods and respective service for it. So that's our deploy Kubernetes logic. Now there's one thing that we need to update in the deployment file in order to use the secret that we are creating here to tell Kubernetes from where to pull the image that is specified in the deployment file. So that is going to be a quick adjustment here in the deployment file. We're going to add an attribute inside the specification of the pod. So on the same level as containers, we're going to add what's called image pull secrets, and name will be a name of the secret that holds the information about the Docker registry. And that's the name of the secret that we have here. That's it. So obviously you can have multiple applications inside your Kubernetes cluster that are coming from different container registries. So for each one, you can actually specify own registry pull secrets, right? And we could also parameterize this, but we have the same value for all the services, so we don't need to do that. So let's update deployment file. Now our deployment file is fully ready, service.yaml file is fully ready, and our deploy logic is also completed. As a next step, before we actually execute the pipelines, we need to install kubectl on the GitLab runner, which will execute this job, which is logical because the GitLab runner will be running kubectl command. So kubectl command should be available on the runner. So let's go ahead and do that. So I'm going to SSH into my GitLab runner machine. This is the remote machine that we have registered for as a runner for our microservices application. And if I do kubectl here, I get a command to install it. So let's go ahead and do that. And this is giving us some warnings. So we can also go ahead and check the alternative installation guide, install kubectl on Ubuntu. And we're going to go with the native package manager option. So I'm just going to copy these commands. So we're doing the update. Then we're installing all the necessary packages for the kubectl, downloading the Google Cloud public signing key, as it says, adding the Kubernetes apt repository, again doing the update, and now we should have a kubectl package available to download from that edit repository. So let's wait for that. And if I do kubectl, now we have the command available. Awesome. So kubectl is installed. Now we should also check that we have the env-subst command available locally. So I'm gonna execute that. And we do, it's actually waiting for the input. Otherwise you would get command not found, obviously. So if you're using a local runner for this demo or some different runner, make sure it is also available. It is actually by default on this Ubuntu version, as it seems, it is already installed, so we don't have to do anything. If you don't have the tool, then go ahead and install it because we need that as well. And I'm going to link this installation guide for the env-subst command so you can use the respective command for your environment that you're using. So go ahead and make sure you have that also available on the GitLab runner. Cool. And with that, we actually have configured everything that we need in order to run the pipelines for our services. So I'm gonna commit those changes on the CI templates, and going back to the front end, we're gonna configure the pipeline to execute deploy to Kubernetes job. And this final step is super easy because all the logic is in the CI templates. So here we only have to change the reference to the correct file. And we call this one deploy Kubernetes. So that's what we're referencing here instead of deploy. This will make the deploy job available inside that we're referencing right here. And now we have to simply provide all the needed environment variables. And that's it. So we don't need the server, host, and endpoint anymore because we're not SSHing into an EC2 server to deploy to it. We're connecting directly to Kubernetes. Now let's make sure that all the environment variables are being set. So these ones, basically, the ones on the right side, are taken from the environment variables available inside the pipeline. So this is a predefined variable, microservice. We have that already. Service version, again, we have that as well. Microservice, service port, there you go. Replicas, let's specify that one. And let's say we are gonna run 2 replicas of this front end. Kubeconfig is coming from the global variable, and let's see, all of these are already available, and there you go. Our pipeline for front-end service is completed as well, and we can rename it back to gitlab.gitlabci.yaml. So when I commit this now, GitLab will start a pipeline, and hopefully this will deploy front-end service to our Kubernetes cluster. So commit the changes and wait for the result. And let's wait for the result of pipeline execution. And our pipeline actually failed in the deploy phase, and let's see why. I'm gonna jump into the logs. And the reason is because you see in the error message is that GitLab user, or the service account that we associated with the GitLab user, is not allowed to create secret in my microservice namespace, which is logical because we didn't allow that specific permission in the role when we created that. So I actually forgot to put secrets resource also on the list of permissions. for CI/CD user. So we're gonna fix the role and then run the pipeline again. And this is actually one of the things you may have issues with when creating dedicated users for different services and giving it limited permissions, because you may sometimes forget to assign a permission of some specific thing that you actually need to do with that user. But that's an easy fix. So I'm gonna go back to the cluster. Let's go back to our local Kubernetes admin user. So I'm gonna set the kubeconfig file back to the admin user's kubeconfig file. And let's actually adjust the CI/CD role.yaml that we created. And we're gonna add the secrets on the list. And you also see this in the error message that secrets resource actually belongs to the default API group, which is this one, the core one, which is empty. So we're gonna list it here as well. Again, this is something Kubernetes specific. If you want to know how the API groups work and which resources belong to API groups, you can check out my other Kubernetes resources that are dedicated to learning about Kubernetes, including how all this works. Here it's enough to know that we're adding a permission to get, list, watch, create, update, patch, delete secrets in the my microservice namespace to this role. So we're gonna save this and apply. There you go. We don't need to adjust or update anything else because now Kubernetes knows that this role has permissions to do all these things. And whenever a service account tries to connect to it that has this role associated to it, it will allow it to create, update, etc. secrets in the my microservice namespace. So now let's actually run the pipeline again. And I'm gonna manually trigger it using run pipeline. And let's wait for this pipeline to deploy. And this time the pipeline was successful. We have a successful deploy job, which means the front-end application should actually now be running in the cluster. So let's go back to the terminal and check that the front-end microservices deployment and service resources have been created. So I'm going to do kubectl get service in my microservice namespace, and we should see the front-end service here. Awesome. Let's also do get deployment in the my microservice namespace. There you go. We have 2 pods out of 2 desired pods running. Let's also check the pods. And there you go. They're both in the running state. Awesome. Of course, we want to access our application to make sure it's also running properly and it's accessible from the browser. And since we're using internal services, which means the services are only accessible from inside the cluster, we can use what's called kubectl proxy to access our front-end service locally from the browser. So kubectl proxy basically creates a proxy to Kubernetes cluster and makes any service available locally. So we can access it easily without having to configure ingress or external service or whatever for our applications. Of course, this is for test purposes only, so that you can test it locally. In real cluster, we would configure an ingress controller or a load balancer or some kind of external service and so on to allow users to access our applications. But again, as I said, this is outside of the scope of this course. This is something Kubernetes specific. Here we are focusing on learning how to deploy from GitLab CI/CD to Kubernetes. So let's create that kubectl proxy using kubectl port forward command. And we're gonna do service, front end, and then basically port locally that we want to forward it to. And let's see. And I actually forgot the namespace because we have to specify that as well. Let's try again. And there you go. So now our front-end service is forwarded locally on localhost port 3000. So if I type this in the browser, I should be able to access whatever is running in the cluster. Awesome. And now to validate that deployment is working for other 2 services as well, let's go ahead and deploy them as well. So let's leave our service and deployment manifest files open. Let's go to the product service And this is actually going to be a very easy adjustment because we have prepared everything already. So this is going to be minimal work. So I'm going to switch to Web IDE. I'm going to create a folder called Kubernetes. And inside this folder, we're going to create deployment.yaml and service.yaml. And because we have created this in a generic way, I'm actually able to simply copy the manifest files from frontend service exactly as we have it there, no adjustment needed. And in the pipeline code, we're going to reference the correct job, which is deploy to Kubernetes or deploy Kubernetes. Let's actually check that. It's deploy Kubernetes, like this. These three variables that we have to set, and then additionally we have these replicas as well. And let's also do 2 replicas here. Again, that's a best practice in Kubernetes to run at least 2 replicas for each service, so you're not relying on just one instance of your service running. And that's it. So we have the correct deployment job, we have all the variables set, and we have our Kubernetes manifest files. And if I commit this should trigger a pipeline that will deploy product service to Kubernetes cluster. Our products pipeline was also successful, which means we should have a deployment and service resources for these microservices as well in the cluster. Let's go ahead and check that. Let's actually leave this terminal running the port forward command. I'm going to open a new one. And since this is a new terminal session, we have to set the kubeconfig here as well. So let's go ahead and do that to the admin users kubeconfig. And now if I do kubectl get service in my microservice namespace, we should see product service was also created. Let's check the deployment as well. There you go. Both pods are running and they're in a running status. Now this means if we access our front end locally, let's actually make this a little bigger. And if I click on view, I should get response back from the product service. And now let's do the same for the shopping cart, and it is working. If I click on shopping cart view, nothing is returning because we still need to deploy that. And we would see some connection issues here because frontend cannot find. However, if I check the pods, even though we kind of broke the application, Kubernetes automatically restarted the pod and now it's up and running again. And you see 1 restarts right here. And also note that we have 2 instances of each service, which we just configured by setting replica 2. And that was it. We don't have to manage any kind of load balancing or which front-end pod gets the request coming from the browser and which of the product pods it's gonna communicate to and so on. All of that is done and handled by Kubernetes. We can scale this up to 10 instances just by setting a replica, and we will have no application configuration efforts on that, which is amazing. So our pods are up and running. If I refresh, we see the front-end application. If we had done the same with Docker Compose deployment, meaning clicking the view of a backend that doesn't exist yet or isn't deployed yet, the application would crash and you would have to manually restart the front-end service. So that's one of the advantages of using container orchestration tools. So as a final step, let's repeat the same process for shopping cart so we can complete our demo and make sure it works as well. So again, going back to Web IDE view, we're going to create Kubernetes folder, and inside we're going to create deployment, with the same exact configuration, and service.yaml. like this, and also adjust the pipeline configuration, deploy Kubernetes file that we're referencing here, and we can set these to 4 replicas. Let's say the shopping cart service is getting a lot of heavy load, so we want to distribute the load over 4 replicas, and that's it. Let's commit this, run the pipeline, and make sure everything works in the application. And finally, we have our shopping cart pipeline completed. And if I go back to the front-end application and click on View Shopping Cart, there you go. We get a response back from both of the services. And obviously, we have them running as well in the cluster as 4 replicas that we started. So with this, we have actually successfully deployed our microservices application to Kubernetes cluster and configured build and deployment pipelines for our services with a few best practices in place. Now, as I said, in a Kubernetes cluster, you would proceed with the setup to configure an ingress controller to access your application and configure some other stuff for your microservices. But essentially, we have learned the core parts and concepts of how to connect to Kubernetes cluster generally and how to build pipelines to deploy to the cluster from GitLab CI/CD platform. Now, I'm going to mention here to make sure you clean up and delete all your services running on these cloud providers. We have a GitLab runner that is running on an EC2 instance. We have a Linode Kubernetes engine. So make sure to delete those instances and services once you are done learning to make sure you don't get charged by these cloud providers. Awesome, we have completed our course. We have done a couple of demos where you learned real life examples and configurations of CI/CD pipelines for monolith as well as microservice applications, deploying to Docker Compose as well as Kubernetes environments, and so on. These were a lot of concepts, a lot of best practices, a lot of industry insights on how these things work. So congratulations for getting to the end of the course and working through the demos with me. We put a lot of effort in making this course as efficient as possible, making all the concepts really easy to understand and all the demos easy to follow, as well as structure the course in a way that it stays engaging and interesting till the end. So I really hope you enjoyed the whole experience. And what's more important, I hope that all the knowledge that you gained here from this course, you will be able to implement it successfully at your work projects, at your own hobby projects, whatever projects you're working on, where you need to use GitLab CI/CD and build pipelines for your applications there. With that, thank you for being one of the students of our course. And if you did like it and it was useful for you, I would really appreciate you giving us an honest feedback on the course or any improvement ideas that you have, so that we can make this course and the future courses even better. Thank you and take care.